In these clips, we see the Japanese ship-based Model 96 25mm anti-aircraft guns in action. These were the most significant guns adopted by the IJN to defend their ships against close-range attacking aircraft. Their combat performance in shooting down Allied planes, though, was considered poor. The intent of this video is to review the configuration and specifications of the Japanese-based Model 96 25mm autocannons, its ammunition, the reasons why the guns were considered poor performers, and its combat effectiveness. This image shows a triple-mount Model 96 25mm anti-aircraft guns located on the IJN I-400 submarine. The left gunner sat here and used this manual crank to elevate the guns from -10 to +85 degrees. The target is tracked by this iron ring sight and sight post. He is also responsible for firing the guns by depressing the firing pedals. The right gunner controls the gun's traverse azimuth by manually turning this wheel in the direction he wants the guns to point. He also tracks a target with his own iron ring sight and sight post. He does not fire the guns. This image shows a twin 25mm gun mount configuration. The location of the elevation and azimuth controls. The firing pedals are located here. Left pedal fires left gun, right pedal right gun. Gun sight rings are missing. The 15-round magazines are shown here and will be inserted into these slots. His hands are on the elevation crank, a single flexible mount Model 96 25mm gun, a battery of single 25mm guns. Note the angle markings on the panel to help in calling out targets. This chart from a June 1945 SINPAC flak intelligence document outlines the classification of Japanese flak. Heavy flak is defined by gun barrel diameters over 75 millimeters, medium 20 to 40 millimeters, and light flak includes machine guns. The Model 96 25mm autocannons are classified as medium flak. Characteristics of medium flak include projectiles detonating on contact, rapid rates of fire, slant range of 7,500 feet, and the projectiles have tracer elements. This page from a 1944 U.S. Navy Air Combat Officers document outlines some anti-aircraft artillery terms. Slant range is a straight-line distance from the gun to the aerial target. This table from a January 1945 SINPAC document on Japanese anti-aircraft armaments outlines characteristics of Japanese anti-aircraft guns. The IJN's 25mm automatic weapon Type 96 muzzle velocity equates to 2,850 feet per second, or Mach 2.6. We will skip these parameters for now as more accurate data is available. The gun's elevation range is between -10 and +85 degrees. This is defined as quadrant elevation. The usual IJN loadout is a mix of high explosive and high explosive tracer. Projectile weight equates to 0.6 pounds. The projectile is fused to detonate on contact, no time delay. Additional characteristics of the gun are listed on this page from an April 1945 SINPAC Intelligence Japanese flak document. The rate of elevation travel equates to 9 degrees per second and traverse travel at a rate of 13 degrees per second. The gun is used in ships and on the land. It is the most formidable weapon the Japanese have in attacking low-flying aircraft. Targets are mostly sighted by an iron ring and sight post, although computing sights are sometimes used. The guns are ineffective at target altitudes above 6,500 feet. This table from a 1945 U.S. Navy document on the Model 96's gun performance lists characteristics of its projectiles. The weight of the projectile is around 245 grams when filled with 9 to 19 grams of an explosive fill, depending on if the projectile has a tracer element. A World War II pineapple-style hand grenade has around 52 grams of an explosive fill for reference. This table shows the trajectory of the 25mm projectile. The x-axis is a horizontal range in meters, the y-axis is the altitude in meters, and the curves in the body of the chart are the projectile's trajectory based on the quadrant elevation angle of the gun. The numbers along the projectile's trajectory are the time of flight in seconds, which can extend out to 40 seconds if fired from a gun with a quadrant angle set to 40 degrees. This outer line is the limit of field of fire. The guns are not effective in striking planes above an altitude of 6,500 feet or 1,980 meters. We can add a danger zone and safe zone on this trajectory plot. The projectiles will travel in the safe zone but not be effective in striking a plane. The bounded fields of fire for the significant Japanese anti-aircraft gun projectiles is shown on this graph from a 1945 SINPAC Japanese anti-aircraft material document. This page from a February 1946 naval intelligence document reviewing Japan's anti-aircraft guns addresses Japanese opinion regarding the Model 96 25mm gun. The 25mm gun was considered the best anti-aircraft gun due to its large caliber size and extensive use. It was also considered the most reliable Japanese anti-aircraft gun. Dual and triple mount guns were superior to an equal number of single guns. Japanese sailors struggled to control the single guns due to their small size, and all single guns lacked computing gun sights. Water-cooled guns were not considered. Crews did cool the barrels by adding wet rags. The gun's design originated from the 1935 French Hotchkiss, which replaced the 40mm Vickers design. Barrel life varied from 3,000 to 5,000 rounds, depending on source. The weight of a single gun equates to 407 pounds, twin guns 2,420 pounds, and triple mount guns at 3,960 pounds. No armor protection was provided for the gunners except on the Yamato super battleship. It was provided for crew blast protection. This table lists the number of guns mounted based on ship. We can add a total column. Battleships were armed with 96 to 150 25mm autocannons. Aircraft carriers between 90 and 150 guns, cruisers between 46 and 70 guns, and destroyers at 22 guns. This image shows a top view of the IJN super battleship Yamato with its 40 triple and 30 single 25mm mounts highlighted. This image shows a port side of the Yamato model display in Kure, Japan. These enclosures were to protect the crew from the gun's blast. This Japanese cargo ship is armed with 8 25mm single guns. The triple mount guns require a crew of 9, twin 7, and single 3. This page lists the 5 reasons why the gun's combat performance was considered poor from the Japanese perspective. The gun's rate of travel is too slow to track fast, low-flying aircraft. This applies to either manual or powered drives. The Model 96's traverse rate of travel is 13 degrees per second, which is 1/3 the rate of travel for the U.S. Bofors at 40 degrees per second from a Bofors Army technical manual. Each 360-degree turn of the right gunner's hand wheel rotates the gun carriage 5 degrees. You can see the hand wheel in action rotating the gun mount. This is too slow to track fast, low-flying aircraft. The gun sight was inadequate for tracking high-speed targets. The gunner needed to track, account for range, and account for the correct lead. The gun's vibration was excessive. Holding the sight on the target with the correct lead was difficult. The 15-round magazine ammo capacity was too small. This reduced the gun's rate of fire. The maximum rate of fire equated to 230 rounds per minute per gun, but due to limited magazine capacity and constant magazine swapping, this rate was reduced to 110 rounds per minute. The muzzle blast was significant and affected gun crew performance. No protection was provided for the crews. This table from a February 1945 Japanese anti-aircraft gun document outlines the effective striking range of various Japanese anti-aircraft guns. The 25mm gun's effective hitting slant range equated to 4,500 feet, or 1,371 meters. We can reduce the plane's danger zone from the altitude limitation of 6,500 feet to a slant range of 1,371 meters. This table lists a range at which Japanese gunners would open fire and cease fire based on captured Japanese documents. 25mm gunners would open fire and cease fire at ranges of 1,640 yards or 1,500 meters. Even though the 25mm projectiles will travel through the non-effective zone, the likelihood of a plane projectile strike is minimal. The projectile's danger zone time of flight will be around 2.8 seconds. These 5 gun deficiencies pointed out earlier lead to the reduced projectile's effective strike zone. So how combat effective were the Japanese 25mm anti-aircraft guns? During the Battle of Midway, of the 144 Allied planes that were destroyed, only 2 to 5 were shot down, depending on source, by the ship's anti-aircraft guns. The remaining were destroyed by the convoy's cap and other causes. On April 7, 1945, 386 planes were sent to attack the Yamato battleship and her 9 escorts, 1 cruiser and 8 destroyers. That's a total of 372 25mm anti-aircraft guns. The Yamato, a cruiser, and 4 destroyers were sunk, for the loss of 10 naval aircraft. All 10 plane losses were attributed to the ship's anti-aircraft guns. That's 1.67 planes lost for each Japanese ship sunk. In actual attacks by VT-15's TBF Avengers against the IJN battleship Musashi, torpedoes were released at distances from 1,500 to 1,800 yards from the ship. From this October 1944 Battle of Leyte Gulf Aircraft Action Report, the Avengers will be executing their torpedo attacks just as a plane is within range of the ship's 25mm anti-aircraft guns' open fire distance of 1,640 yards. The gun's lack of a quick tracking system, low ammo capacity, inadequate gun sight, and vibrations will reduce their effectiveness in striking low-flying, high-speed aircraft. Low Allied plane losses during ship attacks can be mostly attributed to the 25mm gun's weak performance. If you have found this Japanese Model 96 25mm anti-aircraft gun review interesting and informative, please consider commenting, liking, and/or subscribing to World War II U.S. Bombers.